use putty. Okay. Then what else? Telnet?
The commands.
Telnet? Then
Internet.
SSH? What are the commands you use?
Commands are also
What commands? Examples?
like ls.
No. Those commands are for a computer. You can't use that. Anything related to network.
R users.
R users, yeah, R user, R login.
PS also.
Pardon?
PS minus A.
No, PS is computer.
That's
That's
the
for only one
process.
computer. That's not. You're not going to another computer for
Then
that.
R
Right?
users.
RPC info. I can say RPC info and another computer's name. Oh, then is
If
network.
config.
Then network, right? Network. Maybe we don't talk now, right? Okay. So RPC for another computer also maybe has to go to another computer. So maybe we can say that is also part of this, right? Okay. So all these things has to happen, right? You want to send this furniture to another country. How you are going to send? This furniture is here. You want to send it to another country. How you are going to send? First, what do you do?
Like,
You have to deassemble.
Yeah.
This is nothing much to deassemble. We assume that you are going to send a toy car. Toy car, children, toy car, big car, right? So you want to first deassemble.
yes.
First, what will you remove?
The legs.
Wheels.
Yeah,
No, I'm
if
talking
it's
about the
there.
car. Okay.
Oh, car you are talking about.
Yeah, I'm talking about the car. Okay, sorry.
Deassembling human.
Okay. So I'll remove the wheels first, right? Right? Everyone like to remove the wheels first. Okay. Then next, what do you do? Then this guy is removing the wheels. Okay, the car won't run. Okay, this guy is removing what? Different departments. Removing the engine, the small engine or battery. Like that, different people are removing different things. To remove, what do they use? They use their finger.
Tools.
They use different types of tools. The car gadget can have 25 screwdrivers, right? So all those screwdrivers has to match the screws in the car, right? So when you go and buy from any shop, the screwdrivers all standard. All the screwdrivers are standard. Standard. They follow the
Yes,
standard. But they are different sizes. But they follow the standard, and they make the screws also standard. Why the standard is necessary?
Then only the other machine can.
Yeah, because if there is no standard, I make my own screwdriver, you make my own, I make my own plier or something, right? So how will it work? No, you know what I mean? So there should be some standard. So when these people started sending, using networks, there were no standards, right? Everybody were talking about, if I'm creating a router, so I don't follow the real standard. So that router will work only for my protocols or my applications or my network, my type of network, right? You know what I mean? That's a problem, right? So everybody should follow the same standard. So there's an organization called ISO, International Standards Organization, you know that, right? So they said, this is how you should prepare your router. This is how you should prepare your IP protocol. This is how the IP protocol should be. This is how the TCP should work. Everywhere in the world, whether you go to the moon also, this is how TCP should work. Those standards are defined in this place, in these places, right? Say for example, I have different sections here. In this section, how to make a router. How routing protocols has to be done when they write the programs, right? How they have to be coded, right? How network address should be, how host address should be, how the MAC address should be. Can I give a MAC address which is no longer than 48 bits, shorter than 48 bits? No. So those standards, all of those are defined in this model, right? So this model is called OSI model. Okay? Open systems interconnect. So open systems, it can be from any maker. Router can be made by anybody. This guy can be made by anybody. Bridge can be made by anybody. But they will interconnect.
So OCI helps to make all
That is a definition. Okay. So if I want to make a router, so then I will go to this layer, the definitions in this layer, so many pages, right? So I will read, oh, this is how I should make my router. Then it will work with anybody in the world. Okay? anywhere in the world, right? With any operating system, any protocol, right? Okay. So this is what we are going to mainly do in this course.
What does ISO do?
International Standards Organization. This is International Standard Organization.
Oh, this is just an
Organization, okay.
that follows the standard.
Yeah. So they got together and they said, okay, this is how we should make all the people in the world make their devices, protocols, applications, right? Everything. Okay. In this layer we are talking about what? In this layer we are talking about IP address. In this layer we are talking about MAC address. So this layer should have a destination IP. Okay. This one should have a destination MAC address and the source MAC address. Okay. So like I am labeling some product, I am going to send a package to somebody, right? Inside the package I have the name of the person, right? And I am covering with the courier envelope. There I am putting the address. So like that, I am encapsulating a package. So there will be more encapsulations here or more encapsulations here. When you go down, there will be more encapsulations, right? More encapsulations, right?
What is in?
Encapsulation means like wrapping it with the addresses. Okay? I am giving the destination IP address here. I am giving the destination MAC address here. And the source MAC address also. Okay? So I am encapsulating the packets. Okay? But when you had the car first, you called it car. Car without wheel, how are you going to call it? You have to give a different name, right? Car without engine, you have to give a different name. So likewise, when the application, when the data from here flows down, the name also changed, right? Because it's not the real program anymore, right? So I have an application here, a data component, which is about 2 gigabyte. Can I send 2 gigabyte from here to here? Can I send a car from here to there? In my example, can't. So I have to break that into pieces, right? So these are the people breaking that, right?
So it's not broken at the top.
At the lower layers. Top layer I can't break because I'm writing that, or users are using it. So I can't break in that layer.
So it breaks as it flows.
As it flows, it has to be broken. It has to be broken. So we give different names. So can I send this 2 gigabyte from this computer to this computer through the wire, through the cable?
Yes.
2 gigabyte through the cable as?
No, you can break it down.
Yeah, it has to be broken down to bits, right? Computer communication, we have to send, in the communication we send information in the form of bits. So we are talking about bits here, right? Bits. Bits means like electricity, no electricity, right? Some sort of, easy for you to understand that way, right? So that's the way the information goes. Like if I want to send you a message, I will say, okay, I'll turn on the light, turn off the light, turn on the light very fast and so many times. Then you will understand, okay, I'm calling you to come for lunch, something like that, right? So like that only computer will understand, right? But I have to program the computer in that way, right? In a simple way. But here, we are not talking about bits, we are talking about frames. So the name we give here is frame. The name given is frame. Frame, right? Frame has, does the frame have source MAC address and destination MAC address? Yes. Here we talk about packet, right? Or any other name? Packet, right? Okay. Here we say segment.
Yeah, packets, datagrams.
Or datagrams. Here only we can call datagrams. If it is a UDP, we call datagrams. There is UDP also here, right? If it is UDP, we call datagrams. If it is TCP, we call